Hello everybody, I'm Angayarkani. I'm here to teach you certain basics of mathematics. Knowing yourself is the beginning of all. It is the quotes by Aristotle. So spin around for learning more. Let us start with number theory. Number theory is nothing but study of integers. First we will start with notations or symbols. Notations or symbols are used to express an idea in writing. We have the agenda, common notations, integers, the basics, introduction, making integers out of integers, side note, definitions, exercises. Thank you. First we will see what are the common notations. A vertical line B indicates relationship of divisibility. For example, 8 vertical line 32 indicates 8 divides 32. I think you will be able to understand what I am saying. That is, A vertical line B indicates B is divisible by A. Like we can say 36. 36 is divisible by 4. So 4 vertical line 36 is true. Next, A implies B indicates that symbol is called as implies. That is equal to, and the arrow mark indicates implies. For example, x plus 1 equal to 4. It is obvious that x is equal to 3. Therefore, x plus 1 equal to 4 implies x equal to 3. N factorial, where n is a positive integer. For example, if we take 6 factorial, when we write a 6 factorial, the factorial stands for n minus 1. So, 6 factorial equal to 6 minus 1 in 6 into 6 minus 1 factorial, which can be written as 6 into 5 factorial, which can be further implied as 6 into 5 into 4 into 3 into 2 into 1, which is equal to 720. Next, GCD of A comma B. GCD is nothing but greatest common divisor of A and B. For example, GCD of 10 comma 15 is 5. That is, what is meant by greatest common divisor? You have to calculate the divisor, a common divisor of a divisor that should divide both A and B, and it should be the greatest of all. Other than something bigger number will not divide A and B both as a common divisor. So for GCD of A comma B, the divisor should be common to both A and B. It should divide both A and B, and it should be the greatest common divisor. And here for 10 and 15, 5 divides both 10 and 15. 5 divides 10. 5 2s are 10. 5 divides 15. 5 3s are 15. And any larger number other than 5 cannot divide both 10 and 15. So the greatest common divisor is 5. And LCM of A comma B is the least common multiple of A and B. That is, choose a multiple. For example, if we take LCM of 10 and 15, Multiples of 10 are 10, 20, 30, 40, etc. Multiples of 15 are 15, 30, 40, 45, etc. So you should choose the multiple which will be both common, and it should be the smallest number which could be the multiple of both 15 and 15. And here it is 30. 10 threes are 30, 15 twos are 30. 30 and 30 are common, least common multiple of 10 and 15. Next, maximum of a comma b. It indicates that maximum of the group of real numbers. Max of a comma b selects a number which is the maximum of the given set of numbers. For example, max of 1, 2, 3, 9, 8 is obviously 9, the biggest number in the group of real numbers. Next, minimum of a comma b. Minimum of the group of real numbers. Example, minimum of 4, 3, 2, 6, 5, 9 is nothing but 2. That is, minimum of a comma b means it is the smallest number of the group of real numbers. Next, a 3 lines, b mod m. A and b are congruent modulo m. A and b are congruent modulo m. That is, this indication A triple line B mod M is, what does it mean is A and B are congruent to modulo M. That is, which can be explained as difference between A and B is a multiple of M. Example, 16 and 1. 16 minus 1 is 15, which is a divisible of m. So here we are giving value to a and b as 16, and a is 16, b is 1, m is 5. The difference between a and b means 16 minus 1, which is equal to 15, which should be a divisible of m. 5, if in this case 5 is the multiple, 5 is m. So difference 15 is a multiple of 5. 5 into 5 3s are 15. So 15 is a multiple of 5. Hence the condition is satisfied. And here we will see integers, the number line. A number line can be vertical or horizontal. This is useful for addition, subtraction, multiplication, etc. Count down from 3 to minus 1. From 3 to 0, count 3. From 0 to minus 2, count another 2. Total difference is 3 plus 2 equal to 5. Difference between 3 degrees Celsius and minus 2 degrees Celsius is 5 degrees Celsius. In this way, integer timeline is useful in practical calculations. Integers, the basics. There are different kinds of integers: positive integers, negative integers, and 0. Exception: number with at least one non-zero digit after decimal point is not an integer. That is, if we write 5.0, it is an integer. But if we write 5.01, if any number 1 to other than 0 comes, it is not an integer. Because we can't count from 0 to that number 1 unit at a time on the number line. While calculating with number line, We cannot use point 0.01 or 0.02 to count one unit in terms of units. Like if you choose 1 unit, it would be like 1, 2, 3, 4. If you choose 2 units, it will be like 2, 4, 6, 8. And 3 units, 3, 6, 9, etc. But if you choose 5.1, one unit will be 5.1 and then other unit will be 10.2, like that the counting would be confusing. The basic intention of timeline is nothing but counting, and it gets into the problem when we use decimals, the 2.02 something like that. Integers are numbers to count both forward and backward for counting whole objects like people, car, etc. That is, integers in the number line are to count forward and backward. Positive integers or natural numbers are counting numbers to count objects. The positive integers are nothing but natural numbers 1, 2, 3, 4 up to infinity. They are called as counting numbers as they are used to count, such as 1, 2, 3, 4. Whole numbers are 0 and positive integers. When we include 0 with natural number, it becomes the whole number. Joe says, I booked 5 tickets for the concert, but now 2 more friends want to go. How many tickets do I need? So Joe is saying that she is having 5 tickets. 2 more friends want to join them. And how much extra ticket does she need? Like she is having already 5 tickets. She needs 2 more. So it is 7 tickets she want for all the friends. And Nick says, how many eggs are in the fridge? There is a box of 6 and 1 in the egg tray. Here he is having already 6. So now he has 1 more egg. So it is 7. Next, Matt. They asked for 3 coffees and 4 teas. How many drinks do I need to make? He has to make 3 coffees and 4 teas. So 3 coffees and then 1, 2, 3, 4, 4 teas. So it is 7. So all the calculations sum up to 7. Explanation with example. In an empty bag, drop 1 marble and have 5 marbles with you. Drop 1. Drop 1 by 1 5 times. So totally you will have 6 marbles in the bag. Counting backward. The bag is having 6 count of marbles. Taking 1 by 1, you will get 6 minus 6 equal to 0 marbles, emptying the bag. The concept is negative integers are used to subtract objects from a group, called background counting. So if you want to count backward, you can use the negative integers. Making integers out of integers. Integers are used to count, which in turn develops into addition, subtraction, multiplication of group of integers, which always result in an integer. That is, as I said before, integers are nothing but counting numbers. But counting develops into addition. Addition is counting, subtraction is counting, multiplication is counting. As three of these numbers are used in counting, we can say that if you do any operation with this any integer, the resulting number would also be an integer. So using integers, you make different integers. Problem 1. Do the problem by yourself so that you will get an idea of how to do a max problem. 2 plus 4, 2 plus minus 4, 2 minus 4, 2 minus of minus 4, 2 into 4, 2 into minus 4, minus 2 into 4, minus 2 into minus 4. Problem 2, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Problem 3, 1 into 1, 2 into 2, 3 into 3, 4 into 4, 5 into 5. Problem 4, 6 into 6, 7 into 7, 8 into 8, 9 into 9, 10 into 10. Side note, products of integers with themselves. You are going to multiply one integer by another integer. Every integer less than 100 is the product of natural number by itself. Definitions. Fast counting. Addition and subtraction are just fast counting. So every result is an integer. So we are telling that addition and subtraction and multiplication are just counting. So when you count two integers, you will get only another integer. Multiplication is repeated addition, so it comes under fast counting. And so the result is an integer. Whole number exponents are repeated multiplication, and hence the result is an integer. Whole number exponents, for example, 2 to the power of 2, 2 to the power of 2 can be written as 2 into 2. 3 to the power of 2 can be written as 3 into 3. So whole number is a repeated multiplication, which in turn is fast counting, and so the resulting number is an integer. So in case of addition, subtraction, multiplication, whole number, exponent, everything is the result is an integer. Definition. Perfect square. 2 to the power of 2 is a perfect square, which is equal to 4. Perfect cube. 2 to the power of 3 is a perfect cube, which is equal to 8. Perfect power can be defined as at least 2 to the power of 2. It includes perfect square and perfect cube. That is, perfect power should be at least 2 to the power of 2. 2 to the power of 1 is not a perfect power. 2 to the power of 0 is not a perfect power. At least 3 to the power of 2, 5 to the power of 2. Minimum power should be 2. Other than that, perfect powers are 2 to the power of 6, 2 to the power of 9, 2 to the power of 4, 6 to the power of 8, 10 to the power of 9, etc. Then let us see exercises. Subtract one natural number from another. Is the result always a natural number? You have to subtract one natural number from another and then find out whether the result is a natural number. And then product of two natural numbers is always a natural number. Verify. Divide one natural number by another. Is the quotient always a natural number? Find all the perfect squares between 100 and 200. How would you find the perfect squares between 100 and 200? 10 into 10 is nothing but 100. So 11 into 11, what is 11 into 11? 12 into 12, up to the answer should be within 200. Until that you have to find the perfect squares. 10 square, 11 square, 12 square, etc. Thank you for supporting me. You, the audience, mean so much to me. I want to meet the corners of the world, which would happen only if you audience support me. So do like, share, comment and then subscribe my videos. Thank you for watching. Thank you.